Unit 1.1, can change occur at an instant? First, let's go over some terminology. The rate of change is delta y over delta x. The secant line is a line that passes through 2 points. The tangent line is a line that touches the graph at any one point within a small interval. An average rate of change is a change that takes place over an interval. We use the secant line for this. An instantaneous rate of change is a change that takes place in an instant, and we use the tangent line for this. The average rate of change is the slope of the secant, which is delta y over delta x, which is y2 minus y1 over x2 minus x1, which is rise over run. And then we're going to be focusing on nonlinear relationships, and nonlinear relationships do not have a constant rate of change. So now that we're done with terminology, we can start going through some practice problems. So for number 1, Mr. Brust's distance from his house is modeled by the function d of t. While riding his bike to the store, he realizes he dropped his wallet and turns around to find it. After finding his wallet, he finishes his ride to the store. Okay, for part A, what is his average speed or rate of change for his trip to the store if he arrives after 8 minutes? So from here, we could draw a secant line from the origin to 8 minutes. And then we plug in the points of y2 minus y1 and x2 minus x1. So our y2 is 1300 minus y1, which is 0, over 8 minus 0 equals 1300 over 8, which equals 162.5 meters per minute. Part B, what was his average rate of change between 2 and 6 minutes? So we go over to our graph and draw a secant line from 2 to 6 minutes. We plug in our values. So y2 is 800 minus y1, which is 1050, over x2, which is 6, minus x1, which is 2. This equals negative 250 over 4. Which simplifies to, it doesn't simplify, equals 62.5 meters per minute. Part C, what was his average rate of change between 2 and 3 minutes? So we draw a secant line between 2 and 3 minutes, which is right next to each other. And we plug in y2, which is about 1100, minus y1, which is 1050, divided by x1 minus x2. This equals 50 over 1, which is just 50 meters per minute. For part D, it's asking for instantaneous rate of change. So give an example of how to calculate a rate of change that will give a close estimate to the instantaneous rate of change at t equals 2. So at t equals 2, we draw our tangent line. And then we do y2 minus y1 over x2 minus x1. So y2 would be 1050 minus about 900 over 2 minus about 1, which is 150 over 1, which is just 150. So the rough estimate of the instantaneous rate of change at t equals 2 would be 150 meters per minute. To clarify, the points 1 and 900 were taken from another point in the tangent line right here. So for number 2, B of T represents the buffalo population in the United States where T is measured in years since 1800. Part A, what does B of 90 represent? So we know 90 equals T, which is time in years. So we know B of 90 is the buffalo population 90 years after 1800 or 1890. For part B, what does B of 50 minus B of 0 over 50 over 0 represent? So we know this is a rate of change formula. So this represents the rate of change in the buffalo population after 50 years. So for part C, what does B of 32 minus B of 31.999 over 32 minus 31.999 represent? Because the 2 points are very close together, we know that this is about instantaneous rate of change, and these were taken off 2 points on the tangent line. So we could say that it represents the instantaneous rate of change in the buffalo population in 1832.